A force F is equal to T is applied on the block A as shown in the figure at time T is equal to 0. Okay, so we have to calculate the friction force F of the block B with respect to time as shown in the figure. Okay, now over here let us first mark out the forces. This is F force. There will be friction force which acts in the opposite direction. The body will slide towards right, so the resultant will be in the right direction. Okay, there will be a tension force in this direction. So there are two forces which act backward. This is for block A. If I write for block B, there is only tension in acting in the forward direction and a friction force acting in the backward direction. There is a resultant for block A in the forward direction which will be equal to MA. This resultant will be equal to MA for the other block also, okay, by constrained motion. So let us write down the equation of the force for block A. F minus the tension force minus the friction force will be equal to MA. Okay, will be equal to MA. So this is the resultant force when the body starts sliding towards the right hand side. So now the tension force will be equal to friction force minus F minus MA. Okay, this is the equation of the tension for the first block. Now the F is given as T. So T minus the small f will be equal to mu mg minus MA. Now the coefficient of static friction and the kinetic friction for the first block remains same. Okay, it means that this value will remain constant throughout the motion. Okay, this value will remain constant throughout the motion. Okay, so now let us proceed with this part. Let us calculate for block B. For block B, tension is in the forward direction, the friction force is in the reverse direction, will be equal to MA. Now over here we have to plot the F as per, now this is for block A, now this is the friction force for block B. So friction force for block B will be equal to T minus MA. Okay, it will be equal to T minus MA. So now over here the tension is given as, the tension will be equal to T minus MA. So tension will be equal to, I will substitute T minus mu mg. Remember that this value remains constant. Okay, minus MA minus the MA. Okay, minus MA minus the MA. Okay, so now over here this can be written as T, that is the value of tension, minus the mu mg, it remains constant. Okay, let me write this constant as C, minus 2MA. Okay, 2MA can be written as dV by dt. Okay, this is the value of the friction force. Now understand that at time t is equal to 0, the friction force will be 0, which is applicable for all the four conditions. Over here also the friction force is 0, initially over here also the friction force is 0, in all the four cases. Okay, as the time increases, the friction force will go on increasing. Okay, so initially the friction force will go on increasing as the function of time. Okay, the friction force will go on increasing as a function of time. But now in this case, initially when I apply a friction force, this mu mg, okay, this mu mg will initially go on increasing, okay, till the block moves. Okay, till this block starts moving, this block will not experience any friction force, because till this block starts moving, okay, or it just starts moving, the tension over here will be equal to 0. If there is no tension on the block B, the friction force, there is no point of friction force, because the applied force on block B is equal to 0. So initially the friction force on block A will go on increasing, but on block B will be 0, because the tension over here will be equal to 0. Okay, as we can see over here, if the friction force, if the initially the t is 0, at time t is equal to 0, there is no friction force, and as the friction force goes on increasing, till it matches with the tension, till it crosses out, till this value of T matches with this value, there will be no acceleration and there will be no tension in the body. So initially the tension or the friction force will be equal to 0. So options C and D are eliminated because initially the friction force on this block will be equal to 0. Okay. Once the friction force starts acting, it will go on increasing. Okay, it will suddenly start increasing from certain point. Okay, so it will go on increasing at a certain point. Okay, it will go on increasing till a certain point. Okay, so that is, it will go on increasing till this point. Okay, it will go on increasing at this point, and afterwards the friction will become constant. Okay, afterwards the friction force will become constant when the mu k comes into the play. Okay, when mu k comes into the play. Okay, that is the kinetic friction comes into the play. After the kinetic friction comes into the play, it doesn't matter what is the acceleration of the body, the friction force will remain constant. Okay, unless the speeds match the speed of the light, it will remain constant. So the correct option is option number A.